10.5, apply other angle relationships in circles. All right, so we're going to look at some other different angle measurements within circles or about circles to kind of see what their measurements are. So what we know so far are central angles and we know inscribed angles. All right, those are the two that we learned. So we're going to just take a look at some other relationships within circles that are kind of created with chords, tangents, secants, and see what their measurements will be. All right, so here's our first theorem for the section. If a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. All right, so what you kind of need to understand here is that, again, the angle we're kind of looking for is created by this chord with this tangent. Okay, so notice that there's two angles formed. You have the angle on the right hand side, which is labeled number 1, and you have the angle on the left hand side, which is labeled number 2. All right, but what we kind of just need to understand here is that, okay, the vertex of the angle is on the circle just like a inscribed angle. So we know from the definition of inscribed angles and from the theorems we worked with that it's just going to be 1/2 of the arc that it intersects. So since this is just another inscribed angle, that model stays the same. The only thing that's different here is that the arc that we're working with on the right hand side is here, and then the arc we're working on the left hand side is here. All right, so it's just the arc that it's intercepting between the chord, which is here, and the tangent, which is here. So this entire arc here is the arc that it's intersecting. So since that's the arc that it's intercepting, and it's still an inscribed angle by definition because the vertex is on the circle, then it's just going to be 1/2 of that arc. All right, so this is just the cases where we have a tangent and a chord, not like before where we had two chords or two secants. Okay, all right, so let's take a look here. So they want us to find the measurement of angle 1, okay, and they're telling us here that this arc is 210. All right, so this entire arc here is 210 degrees, but we're looking for angle 1. So I know that the measurement of angle 1 is going to be equal to 1/2 of the 210 degrees. Okay, so that's going to give me 105. So the measurement of angle 1 is equal to 105. Okay, let's look here. The measurement of arc RST. Okay, so they want us to find the measurement of this entire arc. Okay, so it's just one of those where we kind of have to work backwards. Okay, so we have the inscribed angle, which is 98. So I know that 98 degrees is equal to 1/2 times the measurement of arc RST. All right, so now if we solve for the measurement of RST, 2 times 98 is going to be 196, and that's going to be equal to the measurement of arc RST. Okay, so that's your second example. All right, and then the third example here, they want us to find the arc of XY. So we're looking for this arc here. Now we have the inscribed angle as 80 degrees, and since this is the arc that's being intercepted by the chord and the tangent, then it's just going to follow the same format as the previous example, right? So 80 is equal to 1/2 of arc XY. So then 160 is going to be equal to the arc XY. All right, and there you go. There's your answer for that one. Okay, so again, it's just understanding. This is another kind of presentation of an inscribed angle. This time, one of those segments is just a tangent, but all the same rules kind of apply here. Okay, all right, so next one. So here we have two theorems, and they all depend on where the location is in terms of the angles. Okay, so the first one is very important that you notice that it's inside the circle. So notice here you have two chords that intersect and they're kind of creating four angles inside of the circle. Okay. The second theorem is outside the circle. So notice that the angle 1, 2, and 3 are all outside of the circle. They do not exist on the inside of the circle. Okay, so let's read the first theorem. It says if two chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arc intercepted by the angles and its vertical angle. Okay, so let's take a look at that case here. So what it's saying, okay, is it's the average of the arc that it intersects as well as its vertical angle, right? So let's look at angle 1 here, okay? So angle 1 is going to be the average of arc A and arc B here, okay? So we know we calculate average by adding the 2 and then divide by 2, right? So the measurement of angle 1 is just going to be 1/2 of the sum of A plus B, okay? Whatever the arc angle is, okay? Then we can easily find, like if we needed to find 2, that could be easy. We could just subtract 180, right? But 2, right, if we label this arc C and this arc D, is just going to be the average of C and D. Okay, so it's very simple when it works inside the circle. Just think of it as the average. It's just taking the average of both sides, and that's going to be the combination that's going to get you the measurement of 1. Now notice that 1 here on the right is equal to this angle 1 on the left because they're vertical angles. Same thing here with 2. So that's why we take the average of the arcs. It doesn't matter which one you take. The average is going to get you the answer in either case. Okay, so that's the importance there. Okay, now let's look at the second theorem here. All right, so the second theorem, I just wanted you guys to kind of focus on. Think of it as you have the angle on the outside, so you need to work with this arc and this arc here. Okay, so it's going to work the same way with the 1/2. But instead of taking the average of the two arcs, you're actually going to subtract the bigger arc from the smaller arc. Okay, so for this theorem, okay, you're always going to be subtracting bigger minus smaller. Okay, and then you're going to divide by 2 or multiply by 1/2. Okay, so it's always the bigger one minus the smaller one, divide by half. The reason why is because we need a positive angle measurement, right? If we do smaller minus bigger, we're not going to get a positive angle. We're going to get a negative angle. And then multiplying by 1/2 is still going to make it negative. So that's not going to work. So it's always bigger minus smaller. And then you multiply by 1/2. All right, so let's take a look at some of these examples here. All right, so let's look at 4. All right, so 4, they want us to find the measurement of y. Okay, so notice that y is the arc. So we have the opposite arc of it here, right? So we're looking for AB, but we only know this much, and we don't know the angles on the inside there in the intersection. However, all right, let's zoom in a little bit. Ooh. All right, so notice that this is 102, so I know here that this is going to be equal to 78, right? Because that's a linear pair. So now I know 78 is just going to be the average of the two arcs that it intersects. So in a sense, y plus 95 times 1/2 is equal to 78. So y plus 95 is equal to 156. Y is equal to 161. So the measurement of y is going to be 61 degrees. Okay, so that's the first example. Again, on the inside, it's just the average of the two arcs that it's going to intercept, right? So you just find the average and then you're good there. Now there was, I guess there can be another way that you can kind of find the measurement a little bit, but we're not going to get into that one. Because you can do it horizontally here, but then it's going to you're going to be guessing a little bit with the arcs, so we don't want to do that. All right, so number 5. All right, so here's one that's on the outside. So again, to set this up, it's all about the model. Once you set up the model, then the math itself is not really hard. So again, you see the situation, we have the angle on the outside. So we know that the angle on the outside, so this 30-degree angle, is going to be equal to the half of the difference between the bigger arc and the smaller arc. So the larger arc here is A, the smaller arc here is 44. All right, so 30 degrees equals 1/2 times A minus 44. So we get 60 is equal to A minus 44. So we get 104 is equal to A. Okay, and then if we quickly check that, right, if we took A, which is 104, and subtract it from 44, that's going to give me 60. And then 60 divided by 2 is going to give me the 30, so there you go, that works out well. Okay, all right, so now number 6 is actually going to take quite a bit of work, all right, and I'll explain why it's going to take more work than the others. Okay, so we actually have no angle measurements to kind of work off of here. Okay, and we have to figure out what this x measurement is. Okay, so the first thing I notice here is that I have some right triangles to work with. Okay, so knowing that I have right triangles, that's actually going to be very beneficial for me in terms of actually solving this, right? Okay, so what do I know about circles? That they all have a radius of 3, right? So that means, or in this case, this circle has all radiuses of 3. So that segment is 3. Originally ST. So the segment from here to the edge of the circle is 3, and then SR is also 3. They're all 3. Okay, so now if I take a look at my right triangle here, what do I have? Okay, and I'll draw it in the same form. Okay, I have that this is 3. I have that this is 5 because 3 plus 2 is 5. But I'm missing the third side here, okay? Now, we don't need the third side. We just need to kind of figure out what the angle here is, right? We need to figure out the measurement of that angle because that's the angle on the outside of the circle, right? And it's 1/2 of it because, you know, this is an angle, but so is this an angle. So we need both of those. Okay, so we need to figure that out. That comes along with some trigonometry, right? So what ratio do I have? Looks like I have opposite and hypotenuse, so that's going to be a sine, right? So sine of this angle, let's call it A, is equal to 3/5. So A is equal to the sine inverse of 3/5. Now, just so I don't go back and forth with the calculator just yet, that's what this little angle in here is equal to. Okay, so let's erase some of this here so we're not getting confused. So this angle here is equal to the sine inverse of 3/5. Now, since these two right triangles are congruent, okay, this entire angle here is equal to 2 of those. Okay, so in reality, what we want to work with is 2 sine inverses of 3/5. And we'll plug this into the calculator once we're all done. Okay, so this is on the outside, right? So since it's on the outside, what's the rule for when it's on the outside? If it's on the outside, the angle is equal to 1/2 the bigger arc minus the smaller arc, right? So here, this is the angle on the outside. That's going to be equal to 1/2 times the bigger minus the smaller. Now, what's the bigger arc? In this case, the bigger arc is x. What's the smaller arc here? Okay, now the smaller arc is actually 360 minus x. The reason why it's 360 minus x is because we know the entire circle is 360 degrees. Okay, so now we have our setup. Let's zoom out a little bit here. We have our setup so we can kind of go ahead and start the process of actually solving it. Solving the equation that we have. All right, so if we start that process, I need to use my calculator here. So we have 2 sine inverse, so 2 times the sine inverse of 3/5 Okay, we are in degree mode, so that's good. Is equal to about 74 degrees, so 74. Or if we did tenths, we could do 10, so 73.7 is equal to 1/2 times x. If we distribute the minus sign there, we get minus 360 plus x. Okay, so we continue, we get 73.7 equals 1/2 times 2x minus 360. Okay, we continue, so we multiply both sides by 2. If I multiply this by 2, oops, sorry, this answer times 2, 147.5 is equal to 2x minus 360. So we add 360, take the answer, plus 360. We get 507.5 equals 2x. Divide both sides by 2. And we get 253.7 is the measurement of x. All right, so again, here was one that just introduced a little bit of trigonometry to work it out. Again, you know, when you're working with this at home, you don't have to leave this part as the expression. If you have a calculator, you know, handy, just go ahead and use the calculator, figure out what that angle is, and then start the process. All right, again, it's just decimal answers, but again, it's still, you know, same thing if you left it as an expression or used a calculator instead. So there you go. That's the example. Again, it's just 3 different kind of variations that we learned today. The first one, if we go a few slides back, is this one. It's just another inscribed angle. So again, it's just going to be 1/2 of the arc that it intercepts. All right, and then you have the 2 cases where it's inside and outside. If it's inside, you take the average of the 2 arcs. If it's outside, you do a difference, and then you take 1/2 of the difference to find the angle on the outside. That's all it is. So those 3 cases are the ones you're gonna have to work with in this section. All right, so hopefully this video helps. All right, see you guys soon.